Hey guys, this is just a really short, quick video because I want to talk about when you have a map, it can either be vector or raster based. So when it's a vector, it's point, line, or polygon. But in raster format, you have this massive grid which goes over the map. And in this grid, every single square within that grid has a pixel value, anywhere between, well, however many categories that you have. And so, but just before I get into that, I just want to talk about the image interpretation keys and cues. So whenever you're looking at a map, there is a tone, texture, shadow, shape or pattern, and also like a context. So depending on the color, this is how you determine the category or like what it is that you're looking at. But anyway, how do you determine a pixel value? So I'm not going to go through all of this because this is way too much to go through, and I learned it ages ago and it's been some time. So you want to go over to SentDex's video. I have his channel, his videos linked in the description. Just click on that link and go on to his YouTube videos, and they will teach you how to determine the value of any pixel by actually calculating it, by actually practically doing it. And he does that through using Python, the programming language. So trust me, you'll learn Python, and at the same time you'll know how to do this, and you'll actually be learning how to make a machine do this for you, because his videos are on machine learning, not actually this, but he teaches you this through machine learning. Anyway, so determining pixel value. So just really quickly, how do we determine a pixel's value? We can use k-nearest neighbors, or we can use support vectors, which uses the stepwise method. So in k-nearest neighbors, first off, we have a bunch of points here, and let's just say that we were to add a new point, this orange circle. And with this orange circle, we don't know if our point is either a plus or a minus. So the question is, how do we determine what it is? We use what's surrounding it. We use k-nearest neighbors. So with k-nearest neighbors, we determine its proximity to other points of a particular category. So this orange circle is around 3 pluses, therefore we would likely give it a plus rather than a minus, because the minuses are on the other side of the grid. And we would use the most of those points. So here we can see there are 3 1s, and there are 2 3s, 2 2s, and 1 4. So there are the most 1s. That means our new point, our point in the center, is most likely to become a 1. That's like the basics of it. And there is also the, the support vectors. And with the support vectors is where essentially we have 2 parallel lines, like 2 linear lines, which go through 2 sets of categories of points. So here you can see minuses on one side and pluses on the other. So we have a line which goes through both of those categories, and we also have a dividing line between both. This is the decision boundary. So when you cross the decision boundary, you become a plus, or you become a minus, depending on which side of this blue line you're on. Anyway, that's just a very short look at this type of stuff. So if you have a map, like something like this, and you don't know what each pixel color should be, it'll be because of these methods, k-nearest neighbors or support vectors. So if you want to learn how to actually code this yourself, go over to SentDex's videos and he'll teach you how to make a machine program that you can test and run multiple times, and it'll teach you how to categorize your data. Anyway, that's it for this video. Hope you guys learned something. Go over to his, check it out, and learn oh so much more. Have a great time.